Have you ever wondered what makes your computer tick, especially when you hear about artificial intelligence? We often talk about the brain of the computer, the CPU, but when it comes to AI, there's another hero in the story, the GPU. Today we're diving deep into why GPUs, or graphics processing units, are the absolute powerhouses behind the AI revolution, and how they're fundamentally different from their more famous cousin, the CPU. Let's start with a simple analogy. Imagine you need to get things from point A to point B. First, think of the CPU, the central processing unit, as a highly skilled, incredibly flexible driver. This driver has a very fast, very powerful vehicle. Give this driver a complex set of directions with lots of twists, turns, and conditional logic, and they'll handle it flawlessly. They can navigate a busy city, figure out the quickest route during rush hour, and even make a few detours to pick up different things along the way. The CPU is a master of sequential, complex tasks. It excels at decision-making and handling a wide variety of jobs one after the other very, very quickly. It's the general-purpose genius that runs your operating system, your web browser, and most of the applications you use every day. It's designed for low latency, meaning it responds to a new, unique instruction almost instantly. Now, let's picture the GPU. The GPU isn't a single driver with a sports car. Instead, imagine a massive sprawling warehouse filled with thousands upon thousands of high-speed conveyor belts. Each conveyor belt is relatively simple. It can't navigate a complex city map or make intelligent detours. It's designed to do one thing and one thing only, move a specific type of package from point A to point B. But here's the magic. All of these thousands of conveyor belts can run at the exact same time. While our single, brilliant driver might move a few complex packages very quickly, the warehouse full of conveyor belts can move a staggering volume of identical packages simultaneously. This is the core difference. The CPU is built for complexity and flexibility, while the GPU is built for massive, parallel throughput. This concept of parallel throughput is the key to understanding the GPU's power. A modern CPU might have a handful of cores, maybe 8, 16, or even 32. Each core is like one of our super smart drivers. A modern GPU, on the other hand, has thousands of smaller, simpler cores. These are our conveyor belts. They aren't as smart or as fast individually as a CPU core, but their strength lies in their numbers. So, where does this trade-off come from? The GPU sacrifices the CPU's incredible flexibility for sheer brute force volume. A GPU core can't efficiently run your operating system or manage your file system. It's not designed for that kind of intricate, varied work. It's a specialist. Its architecture is streamlined for one purpose: to execute the same simple instruction over and over again on massive amounts of data, all at once. This brings us to artificial intelligence. What exactly is AI training? At its heart, training a large AI model, like the ones that generate images or chat with you, involves an incredible amount of repetitive mathematical calculations. Specifically, it involves something called matrix multiplication. Imagine two huge spreadsheets, each filled with thousands of rows and columns of numbers. Training an AI model is like multiplying these spreadsheets together, over and over and over again, billions and billions of times, slightly adjusting the numbers each time to get closer to the desired outcome. Now, think back to our analogy. Would you hire a single, highly paid, expert driver to move millions of identical sandbags one by one? It would be a colossal waste of their talent, and it would take forever. They'd be brilliant at it, but it's not an efficient use of their skills. Instead, you'd use our warehouse of thousands of conveyor belts. Each belt takes one sandbag and moves it. All the belts run at the same time, and in a short period, you've moved millions of sandbags. This is exactly why GPUs are perfect for AI. The repetitive, simple task of matrix multiplication can be broken down into thousands of smaller, identical calculations. This massive parallelism allows AI researchers to perform calculations that would take a CPU months or even years in just a matter of days or weeks. The GPU's architecture is a perfect match for the mathematical foundation of modern machine learning. It's not that the CPU can't do these calculations. It's just that the GPU's specialized design allows it to do them at a scale and speed that the CPU simply cannot match. Originally, of course, GPUs were designed for graphics. Rendering a 3D scene in a video game involves similar principles. To create the image on your screen, the computer needs to calculate the color and position of millions of pixels. Each pixel calculation is relatively independent and can be done at the same time as the others. So the parallel architecture that made games look so realistic turned out to be the perfect tool for powering the AI boom. So we have our CPU, the master of complex, sequential tasks, and our GPU, the king of massive parallel computation. Together, they form a powerful team. The CPU acts as the general, directing the overall operation, while the GPU acts as the army, carrying out the massive, intensive calculations needed for training AI. We've seen how a GPU crunches all these numbers to train an AI model. But that leads to a fascinating final question. After all that math, after all those matrix multiplications and adjustments, how does that sea of numbers turn back into something we can see and interact with? How do those abstract calculations become the pixels that form a stunning image generated by an AI or the words that appear in a chatbot's response? That journey from pure data to tangible output is where the magic truly comes to life. Thanks so much for watching. If you found this explanation helpful, be sure to hit that like button and subscribe for more deep dives into the technology that shapes our world. See you in the next one.